So in this part, we have to calculate the last part. We have to calculate how long is this A to X. First, what we can do, we can find the total resistance of this circuit. How to work out the total resistance of a circuit? Uh, we have in the like we all whether it was at a normal brightness, the current in the current in the lamp we calculated in the first part. We calculated that current using a formula P is equals to VI. So power of the lamp was 9 and the voltage was 6 across the lamp, so it will be 9 divided by 6, that was 1.5 ampere. So 1.5 ampere is a total current because it's a series circuit, so the total current which enter the circuit will be same as total current leave. So there will be 1.5 ampere throughout the circuit which will flow through each component, and same 1.5 will return. That is the total current which will flow in the circuit. Now, first we'll find the total circuit resistance. What is the total circuit resistance? So we have the formula R is equals to V over I. The total voltage is 12 and total current in the circuit is 1.5. So 12 divided by 1.5.
8 ohms.
So 8 ohm. So total circuit resistance is equals to 8 ohms. And out of total circuit resistance of 8 ohms, we know that the resistance of the lamp is equals to 4 ohm. As we calculated in the second part A2, that resistance of a lamp is, if the total circuit resistance is 8 and resistance of a lamp is 4, so how much is the resistance of A and X? So that is equals to 4 ohm. Why 4 ohms? Because we want the total to be 8. As the total resistance of a circuit is 8 and out of 8, 4 ohm lamp is there, so remaining 4 ohm will be there for resistance of A and X. And we know the total length of A, like A and B, resistance and length are directly proportional. So it was having a 5 ohm. The total resistance of the wire was 5 ohm when it was having a length of 1 meter. But if we have a total resistance of a wire 4 ohm, then how much length should be there? X. We cross multiply. So 5x is equals to 4, or x is equals to 4 divided by 5. So x is equals to 0.8 meter. So this from A to X, it should be 0.8 meter. So what we did, we calculated the total resistance of a circuit, and out of total resistance, if we remove the resistance of a lamp, we'll get the resistance of A and X. And after getting a resistance of AX, they already mentioned that when the length is 1 meter for this wire, it was having a resistance of 5. So if the resistance is 4 ohm, how much length will be there? X. Because they're directly proportional, so we just cross multiply and get the length of it. If the diagram was to scale, then no, we don't have to do calculation. Diagram is not to scale, that's why we did calculation. Then another question from circuit, a 12-volt battery is there. So there's a 12-volt battery and it is connected to a 24-watt lamp, and there's a parallel pair of identical resistor X and Y. They have the equal resistance. But if you say this is 12, you cannot write this 12 and 12. This is wrong. Why? Because there is another component in series before that. So some voltage will be here and remaining voltage between X and Y. X and Y will have the same voltage, but remaining of what is there across lamp. So in the question, a 24-watt lamp with a normal brightness have a potential of 6. So if this is having 6 volt, how much voltage will be there? The remaining out of 12, total is 12 and 6 is across the lamp. So how much? 6 here and 6 here. Why? Because this circuit is a combination of series and parallel. So it's like two resistors connected in parallel, and there's another resistor before them, or it can be after, does not make difference to the result. So if it's a 12 volt supply, then, and we say it's a 6 volts here, so remaining voltage will be 6 volts and 6 volts across both of them as they're in parallel. What if there is a 8 volts here? So how much voltage will be there? 4 volts and 4 volts. But total will be equal to the sum, like the total voltage will divide between the component, but in parallel it will be same. Calculate the resistance of a lamp. So to calculate a resistance, we have to use a ratio between voltage and current. We have the voltage which is 6, but we don't have the current. So how to work out the current? We have the power of the lamp and we have the voltage. So using a power equals voltage into current, we'll first find the current. So P equals VI, where P is the power 24, V is the voltage 6, and I is the current. So 6 is multiplied, other side will be divided, so it will be 24 divided by 6. That's equal to 4 ampere. So 4 ampere is the current. 4 ampere is the current in this. And they mentioned that these two are, so we have the 4 ampere current. So to get the resistance, it is voltage divided by current. So voltage is 6 and the current is 4. So 6 divided by 4. That's 1.5 ohm. So this will have 1.5 ohm resistance. And you can see in the question they mentioned that these two resistors are identical. So if we have identical resistor and we have a 4 volts current is 4 ampere is there. So the voltage will divide equally between them. So if it's a 4, that will divide 2 ampere and 2 ampere between them. Determine the potential across AB. So we just have to determine directly. You can say, as you don't need show any calculation here, we have to just determine if it's a 6 volt, so remaining voltage will be there. That is 6 volts and 6 volts. So what is the potential across A and B? That is 6. The combined resistance of a parallel pair of identical for identical resistor X and Y. So we want the combined resistance of the two. Again, you don't have to do calculation, because here we were having 6 volts and this also 6 volt. So if we have like a voltage is divided equally, it means the two components have the equal resistance. So if one side we have out of 12, if we have 6 volts here and we have 6 volts in parallel, what it shows? It shows that this parallel combination resistance is same as the component before that. So if this one was having a resistance of 1.5, so what is the resistance of this parallel combination? That is also 1.5. Is it clear? So again, it's a 1 mark question. For 1 mark question, you're not supposed to write formula. It's just you have to write the answer directly. No, the total is 1.5. For both, it is 1.5 combined. Combined resistance of X and Y equals to 1.5. Then we need for individual the resistance of one of them. So how we can find resistance of one of them? Because like this total X and Y, the combine or the result of X and Y, they're in parallel. So whenever two resistors are connected in parallel, the formula for the total resistance in parallel, that is the product divided by sum, R1 into R2 divided by R1 plus R2. So the combined resistance of these two resistors we want. So example, if I, and they're identical. So if I say this one is A, this one is also A. I'm not using X, otherwise you will get confused with X and Y. So I'm using, say, this is A. So this one is also, or instead of A, if I use this is R, this is also R. So it will be the total resistance of these two is 1.5. So that is 1.5. If this one is R, so it will be R multiplied by R divided by R plus R. So that's equal to 1.5. R multiplied by R is R square and R plus R is 2R. So square will cancel with this and 2 will be multiplied. So what is the resistance of individual? The resistance of individual is 3. Like this is 3 ohm. This is also 3 ohm. Is it clear, this part? Whenever two resistors are connected in parallel, the combined resistance decreases. When two resistors are connected in series, the combined resistance increases. So if you were having two resistors and they were connected in series, and if I say each was having a resistance of 4 ohms, and I want the combine of these two, so we will simply sum them. 4 plus 4, the combined resistance is 8. So whenever the components are connected in series, the total or the combined resistance increase. But if the two components are connected in parallel, the combined resistance of a circuit decreases. So if this one is 4 ohms, this one is also 4 ohms. So what is the combined resistance? It is a product divided by sum. So it is 4 into 4 divided by 4 plus 4. So 16 divided by 8, that's equal to 2 ohm. So it means the total of these two will be equals to 2. And total of these two is equals to 8. So in parallel, when we connected in parallel, the combined resistance decreases. That's why the combined was 1.5, but the individual was 3. Resistor X is removed from the circuit. Why the lamp become dimmer? Look, if we, for example, see, right now, the resistance of a lamp is 1.5 ohm and resistance of this parallel combination is also 1.5. So the voltage was dividing equally, like 6 volts and 6 volts. This was an equal division. But now what they're saying if we remove the resistor X, so if we remove the like each, this was 1.5, this total combined was 1.5, but individual was 3. But now they're saying if we remove the resistor X, so if we remove resistor X in the part of a circuit, so now this Y is having a 3 ohm resistor. So if Y is having a 3 ohm resistor and this combination is in series, so there will be more voltage across Y compared to lamp. So as the resistance of this part increases, so there will be more voltage across the Y, or maybe 8 volts will be there across Y. So remaining 4 volts will be there across the lamp. That's why the brightness of the lamp decreases. So initially, when X and Y in parallel, their combined resistance was equal to resistance of a lamp, so voltage was divided equally. But now when we remove X, so what will happen? The voltage will have unequal division. The resistance of Y is more compared to resistance of a lamp, because lamp is 1.5 where Y is 3 ohm. So if resistance of Y is more, the voltage across Y is more. In comparison, voltage across the lamp will be smaller. Is it clear, the last part?
Yes, sir, clear.
In question 13, state in terms of their structure why metals are good conductors. So why metals are good conductor? Because they have free or the delocalized electrons in the lattice. That's why they're good conductor. A cylindrical metal is there, metal wire is there, which is having a length L and cross-sectional area A, and which is having a resistance of 16 ohm. another cylindrical wire which is having a length half and area double, we have to determine. So whenever you're changing a length, area, so the formula which we'll use R1 A1 over L1 equals R2 A2 over L2. This is a formula when we are using a wire which is made from same material but different length and cross-sectional area. So the formula is R1, the resistance of the first part, A1 divided by L1 equals R2 A2 over L2. This is the case whenever we are changing a length and area of the wire which are made from same material. We did not change the material. So R1 A1 over L1 equals R2 A2 over L2. So R1 is the resistance of the first wire, which is 16. So we write 16 here. A1 is the area of the first wire, which is A, letter A. L1 is the length of the first wire, which is L. So we write L. R2 is the resistance of second wire, we don't know. Area of the second wire is 2A. And the length is L by 2, like half, I can write 0.5 L. Because L by 2 means like half. So when we simplify, A will cancel with A, L will cancel with L. So 0.5 is divided, other side will be multiplied. So 16 into 0.5 and 2 is multiplied, other side will be divided. So that will be R. So 16 into half, it's 8. 8 divided by 2, that's equal to 4 ohm. So this is equals to 4 ohm. Is it clear, this one?
Yes, clear.
Then effective resistance of W1 and W2 are connected in parallel. The W1 was having a resistance of 16 and W2 is having a resistance of 4. And we want effective or the combined resistance. So whenever two components are connected in parallel, to get the combined, it is the product divided by sum. So the total or a combined resistance, it is R1 into R2 divided by R1 plus R2. So it will be 16 times 4 divided by 16 plus 4. 16 times 4, that is 64. And that is divided by 20. So this will be equal to 3.2 and the unit is ohm. So you can see when we work out the combined resistance of parallel, the total resistance will always be smaller than the smallest one in the combination. Like the smallest one in the combination is 4 and the final answer will be less than 4. So whenever two components, two resistors connected in parallel, the combined resistance decrease. If they are in series, the combined resistance will increase. The pair of a parallel resistor is connected to a battery that is made from 3 cells. So we have W1 and W2, like this is W1 resistor, which is having a resistance of 16 ohm, and W2 we calculated, which is having a resistance of 4 ohm, and both are connected to 3 cells. Each cell is having a voltage of E. This cell is having a voltage of E. This is having EMF of E. This is also EMF E. What is the total voltage of the battery or combination of the cell? So it will be equal, because like if I say this is 2 volts, this is 2 volts, this is 2 volts. So what is the combined 6? So if voltage is E for one cell, so 3 cells, the voltage will be 3E. You have to write in terms of variable. Like E represent like the voltage, the value of a voltage. Then the total current from the battery is IB. So there is a current which is coming from the battery, that is IB. There is a current in the first resistor I1 and there is a current in the second resistor I2. So what happened in parallel, the current divide. The total current will divide between the branches. The one which is having a low resistance will have a high current. So more current will flow through the second resistor, which is having a low resistance, as compared to small amount of current will flow through I1. And the total, because the total IB will be equals to I1 plus I2. Like the total current will be equal to the sum of the current in individual branch. So we have to mention which one will be the highest one. So which one is the highest one? So IB is more than I2 and I2 is more than I1. So which combination? The second last combination is correct. That shows that the total current will be more than I2 and I2 will be more than I1. Is it clear this part? Question 14, the figure 8.1 shows a circuit that contain a battery, the EMF, and an ammeter, a 20 ohm resistor, and a component X. So a 6-volt supply, an ammeter, a 20 ohm resistor, and component X. So we consider ammeter having a negligible resistance. So total 6 volt will divide between a 20 ohm resistor and a variable resistor. X is a variable resistor, so it will divide between them as it's a series combination. State the name of component X, so we call that as a variable resistor. The potential difference across 20 ohm resistor is measured with a voltmeter. On a figure, draw a voltmeter. You can use screen annotation where we should draw a voltmeter. We want to measure the voltage across 20 ohm. Yeah, that's right. Voltmeter is always connected in parallel. And if the same question was, we need a voltmeter across X, so it will be in parallel to X. So volt either up or down does not make difference. You can connect it here as well. So it's the same thing. Then the potential across a 20 ohm resistor is varied from 0 to 6. For each value of a potential, corresponding current is measured. So on a figure 8.2, draw a line that indicate how the current is measured, by ammeter, depend on the potential across the 20 ohm. So the idea is that, look, it's a 20 ohm resistor. So if it's a 20 ohm resistor, means the ratio between because we don't have the values here, we have the value 1 volt, 2 volt, 3 volt, and we have the current 0.1, 0.2, 0.3. But how to work out, because ratio between voltage and current should be 20, as it's a 20 ohm resistor. So if it's a 20 ohm resistor, so we can find, so current, if we want to find the current will be voltage divided by resistance. So if the voltage is 1 and the resistance should be 20, because it's a fixed resistor, so its resistance should not change. So 1 divided by 20, how much is the current? 1 divided by 20.
0.05.
So 0.05, so we'll have a value here. Because each is 0.1, 0.01, so 0.01, 2, 3, 4, and 5. So this is 0.05. This we have the first value. Same thing, if the voltage was 2 volts, what will be the current? So how to work out the current? Because if the voltage divided by resistance should give us the current. Voltage is 2, but the resistance is a fixed resistor. So resistance does not change. So 2 divided by 20. What's the answer? 1 by 10. Or we can say 0.1.
0.1.
So it will be 0.1. So we'll have a point here, the second point. If the voltage is 3, so current is voltage divided by resistance. So voltage is 3 and resistance is 20. 3 divided by 20.
0.15.
So 0.15. So this is 0.1, 2.11, 12, 13, 14, 15. And same thing, we will find the value for the current. As we are changing a voltage, resistance is not changing. It is 20, so this will be 0.2. When it is 4, it will be 0.2. When it is 5, so it will be 5 divided by 20. That will be 0.25. And when it is 6, it will be 0.3. So what we'll have a straight line which is passing through origin. even I can do this for one value only. I was just doing it for multiple values to explain you the idea. Because we change the voltage maximum to 6 volts, so we will find what is the maximum current. So voltage divided by resistance. So voltage is 6 and the resistance is 20. So 6 divided by 20, that is 0.3. So when the voltage is 6, the current is 0.3. And we know because it's a fixed resistor, so for a fixed resistor, it should be a straight line with a constant slope, so we'll draw a straight line. That's it. This is a straight line which is passing through origin. It's with a constant gradient. And this is the Ohm's law. It states that if you increase the voltage, the current will also increase. Voltage and current are directly proportional to each other, or the ratio between voltage and current remain constant. A second resistor is connected in the circuit in parallel with the 20 ohm. How the combined resistance of the two compare with the resistance of each resistor? Like, what happened to the combined resistance? Their slope represent reciprocal of R. For current voltage, the question is, we connect another resistor of 20 ohm in parallel to this first one. What happened to the combined resistance? Increase or decrease? If the two resistors are connected in parallel, what happened to the combined resistance?
Decrease.
The combined resistance will decrease in parallel combination. And if the combined resistance decrease, what happened to the slope of this line? Look, because like this was the first graph we were having, it was a straight line, but that was for a resistance of 20 ohm when the resistance is 20. But when we connect them parallel, like two resistors, each of 20 ohm are in parallel, the combined resistance, how to get the combined resistance? The product divided by sum. So it will be 20 into 20 divided by 20 plus 20. So it will be 400 divided by 40, which is equals to 10 ohm will be there. 40 basically, yeah, 40 divided by 4, which is equals to 10 ohm. So, and here the current and voltage graph, what slope represent? The slope represent reciprocal of the resistance, inverse. So if the resistance is decreasing, what happened to the slope? The slope will increase. So the line will be steeper, like it will be above it. So the answer here, you don't have to show calculation or draw. You just have to mention a second resistor in parallel. So the combined resistance of a two in parallel, it will be a straight line because it is a fixed resistor. No, it won't be a curve. Because they are fixed resistor, it will be a straight line but a steeper slope. So how the combined resistance of two parallel compares with the resistance of each resistor? So that combined resistance will decrease. And how the second line will differ? It will be curved if there was a filament. If it is a thermistor, then it will be a curve. But because what happened, like this was a first graph which was having a resistance of 20. If we have another resistor of 10, so for a 10 ohm resistor, we'll have a much steeper graph. So it will be steeper graph for a 10 ohm resistor as compared to 20 ohm, because the slope is representing reciprocal of R. It will be curved if we have a filament. Like example, if the same you want to sketch for a filament, temperature increase, so resistance increase, so slope start to decrease. So it will be a curve for a filament lamp. Yeah, if variable resistor, if you are changing the resistance of variable resistor, it will be a curve. But within the experiment, we usually keep resistance of a variable resistor constant, so it won't be a curve. Then question 15, figure 9.1 shows a circuit which includes a battery with an EMF of 12, a 20 ohm, a circuit, a fixed resistor, and a voltmeter is there. The reading of an ammeter is 0.15. Calculate the resistance of the circuit. So if the ammeter reads the total current as it is in series with the and as it is in series with the battery. So we have the total voltage and we have the total current. So we can use the formula R is equals to V over I. So V is the voltage and I is the current, which is 0.15. So 12 divided by 0.15. What's the answer for 12 by 80 ohms?
Yes.
So this will be 80 ohm. And out of 80 ohm, like this is a total circuit resistance. If this is 80, how much is this? This will be 60. Why 60? Because they are in series. In series, the combined, if we say the total resistance of a circuit in series, if this is R1 and this one is R2, so the total resistance in circuit, resistance of a circuit equals to sum of individual, R1 plus R2. If the total resistance of a circuit is 80 and one of the resistor is 20, we need the second one. So it will move other side. It will be 80 minus 20, which is equals to 60. That's why this will be 60 ohm. Voltmeter and ammeter take some, we consider it is negligible. Like we don't consider, we say there's a, practically, yes, there will be some voltage across it, ammeter, and there will be current in voltmeter, but we assume it is not taking any. The variable resistor is adjusted so that the resistance decrease. What happened to the reading of ammeter? Look, the total resistance of this circuit equals to resistance of 20, like R1, plus resistance of a variable resistor R2. They are saying that we reduce the resistance of variable resistor. So the combined resistance of a circuit will decrease. What happened to reading of ammeter? What happened to the current in the circuit? Will it increase, decrease, or stay same? So if the total resistance of a circuit is decreasing, there will be more charges flow through it, so the current will start to increase. But what happened to the voltmeter reading? Because if the resistance here is less, resistance of a variable resistor is small, so less voltage across it, so less voltage across the voltmeter. So the reading of the voltmeter will decrease and the reading of ammeter will increase. What happened to the voltmeter reading? It will decrease because the resistance decrease, so less voltage across variable resistor, less voltage across the voltmeter. The battery is formed from a cell with an EMF of 1.5. Explain in terms of electrical energy what is meant by EMF. You have to learn this definition of electromotive force, EMF. It means like when we say it's a 1.5 volt, especially, so it means it is a 1.5 joules of electrical energy. If the variable resistor decrease, won't the other resistance? No, other resistance is a fixed resistor. It won't change. That resistance is not changing. Only thing what happened, the variable resistor resistance can be changed. Like first it was 60 and now maybe we turn into 30. So when we turn into 30, the combined resistance of a circuit will be 20 plus 30, which is 50. So if the combined resistance is decreasing, so the current here will increase. But because the resistance of this part is decreasing, so there will be less voltage here. In comparison, there will be more voltage across the fixed resistor. And voltmeter is in parallel to the variable resistor, so that's why there will be less voltage across the voltmeter. So this is a series or a potential divider circuit. A potential divider circuit, if one side voltage decrease, automatically the other side voltage will increase because the total should be constant. How more voltage across, look, for example, if I say I have, this is a 20 ohm, this one is 60 ohm. So the total is 12. If a total is 12, maybe out of 12, there is a 4 volts here and there is 8 volts here. So voltmeter reads 8. But now what happened? We reduce the resistance. Example, we reduce the resistance to 20. So if we reduce the resistance to 20, so now they have the equal resistance. So out of 12, what will happen? 6 volts will be here and 6 volts will be here. So what has happened to the reading of the voltmeter? Originally it was 8, but now it has reduced to 6. And what happened to the reading in the fixed resistor? Originally it was 4 and now it has increased to 6. So in a potential divider circuit, if one side resistance decrease, the voltage across that side decrease, automatically the other side, the voltage will increase. In a potential divider circuits. Or in a series circuit, you can also say. So we have to write the definition of EMF or electromotive force. It's like 1.5 joule of electrical energy is used to transfer or drive the charge. 1.5 volt means 1.5 joules of electrical energy. Drive the charge or move the charge around a circuit or in a closed circuit. How many 1.5 volt cells are connected in series to form a battery? What is the voltage of a battery? The voltage of a battery was 12. So how many, if each cell is 1.5, how many cells are connected? So it will be 12 divided by 1.5. That is equals to 8 cells. So 8 cells were there connected in series to get the voltage or to make the voltage 12. So this is like half of the exercise about the circuits.